Okay, hello everyone and welcome back to my maths homework. The eighth question says the value of summation from n equals to 1 to infinity of negative 1 raised to the power of n plus 1 into n upon 5 to the power of n equals. So n upon 5 to the power of n. It looks like it's a geometric series but with that extra n on the layer. So call this summation s. So you will have s equals to, first of all you will put 1 in there. So you will get, well, first of all just rewrite it in a different format. So like you are trying to find summation from n equals to 1 to infinity of negative of n, and then you have negative 1 over 5 raised to the nth power, right? Something like that. Okay, cool. So first of all, yeah, let's do it. So first of all you will put n equals to 1 in there. So this sum is equal to negative uh, negative 1 by 5, I mean negative 1 of negative 1 by 5 raised to the first power. Then you will have negative 2, okay, and the negative 1 by 5 raised to the second power, then negative 3, negative 1 by 5 raised to the third power, and it will keep going like that. Okay, so if I multiply s by negative 1 by 5, that will give me negative 1 by 5 s is equal to negative 1 and then negative 1 by 5 raised to the second power, negative 2, negative 1 by 5 raised to the third power, and it will keep going like that. And now let's subtract this. So 1 plus 1 by 5 is 6 by 5s, okay, and that is going to be, you got that negative 1 into negative 1 by 5 raised to the first power over there. But then you have this second power which we can combine with this second power. So that will give me negative 1 raised to, okay, into negative 1 by 5 raised to the second power. Then minus 3 minus of minus 2 is just minus 1. Negative 1 by 5 raised to the third power. Then minus 1. And then negative 1 by 5 raised to the fourth power. And it will keep going like that. So that is equal to, what we can do is that we can use the fact that this is like a geometric series, right? An infinite geometric series. So this is just negative of negative 1 by 5, that's just 1 by 5 upon 1 minus the common ratio, but the common ratio is negative 1 by 5, so 1 plus 1 by 5, so we will have 1 by 6 over there. Okay, so that gives me s is equal to 5 upon 36. Cool. So this is 5 upon 36. Okay, so the next question is the sum of infinity, okay, sum to infinity of the series some stuff. Okay, so the sum to infinity of the series 1 upon 1 plus 1 upon 1 plus 2 plus 1 upon 1 plus 2 plus 3 all the way till infinite terms is equal to, okay, so our tr, which is the general term, that is equal to 1 upon 1 plus 2 plus 3 all the way till r. Okay, so that's supposed to be 1 upon r into r plus 1 upon 2, which is 2 upon r into r plus 1, which can further be written as 2 upon r minus 2 upon r plus 1. Okay, so that's nice, right? So now let's sum this up. So summation of tr from r equals to 1, right, from r equals to 1 to infinity, that is, first of all you will put 1 in there, so you will get 2 upon 1 minus 2 upon 2, then plus 2 upon 2 minus 2 upon 3, plus 2 upon 3 minus 2 upon 4, and it will keep going like that. So stuff cancels out, and you see that in fact all the terms will cancel out except the last term, which is negative 2 upon infinity, but that's just 0, so never mind. So that's just equal to 2 upon 1, which is 2. So yeah, that's the answer for this question. So this is equal to 2. Okay, hope you enjoyed.